All right, everyone. So in this video, we're going to talk about how to find the mean of a probability distribution. So just to do a quick review of what a probability distribution is, we said basically it shows all the outcomes of a random variable. So a random variable, basically any value that's determined by chance. So if I roll a die or flip a coin and calculate the number of twos I get or the number of heads I get, we list out all the possible outcomes here and then the probability of each occurring. So for example, we did if I flip a coin 3 times, I could either get heads, none of the three, one time, twice, or all three are heads, right? So we said this includes all the possibilities. I'm never going to get four heads. That's impossible if I'm only flipping it 3 times. So we should have 100% of the possibilities here or 100% of the sample space. So if I add these four together, we do have 8 out of 8, which is 100%. So we also went over the two requirements. We said the first one was everything, all the probabilities should add to one. And if I focus on each of these probabilities, or probability in general, if something is impossible, never going to happen, that's 0%. And if it's guaranteed to happen, that's 100%. So percent is out of 100. So 0 out of 100 is 0, and 100 out of 100 is 1. So all the probabilities have to be between 0 and 1. So negative probability doesn't make sense and over 100% doesn't make sense. So when we're looking at a probability distribution, those are the two main things we want to keep in mind. Does everything add to one in the probability row and do all the probabilities, are all the probabilities between 0 and 1? Okay, so to find the mean, remember mean is just another word for average. Um, so if I want to find the average of a probability distribution, we're going to use this formula here. So remember, mu, the Greek letter is the symbol we use for the average. Um, okay, so we want to find the sum of x times p of x. So we know uppercase sigma here means the sum. So you're going to multiply each possible outcome times its corresponding probability, and then you're going to add them all together or sum them together. Okay, so whatever the first outcome is, you're going to multiply that by the probability of that first one occurring. Whatever the second outcome is, you're going to multiply by the probability of the second one occurring, and you're going to do that for as much as you have. So basically, each value of x, and remember, x has to be numerical, so it'll be a number, times its probability. Do that for every single possible outcome, and then sum them all together. Okay, so let's look at a few examples of this. So for example one, we're going to find the mean of the number of spots that appear when I toss a die. So first thing we're going to do is we're going to make a probability distribution. So we're just looking at the number of spots. Okay, so my random variable will be the number of spots because if I toss it or roll a die, that's random. I can't predict what I'm going to roll exactly. Okay, and then the probability of each. So if I roll a die, we could get one dot, two dots, three dots, four, five, or six, right? So there's no side of the die with 0 dots on them. So the lowest is one and the highest is six. Okay, and the probability that I roll a one, well, on a die, one side has one dot on it out of the six sides total, right? So cube has six sides. And if I roll a two, that's also one out of six. So notice all these outcomes are equally likely because each of these is on one side of the die and there's six total. Okay, and if I think about those two requirements, once again, if you add these all together, you have 6 over 6. So we do have 100%. That's all the possibilities. And each of these is between 0 and 1, right? So 1 out of 6 should be about 60, yeah, about almost 16 and 2/3, or about 17% of getting each possibility. Okay, so to find the mean, remember, my formula says take each possible outcome, so the one, for example, and multiply it times the probability of that occurring. So that's going to be 1 over 6. Okay, then we're going to do that with the same. So 2, so the probability of that occurring is also 1 out of 6. Then the 3 is a 1 out of 6 chance as well. Then the 4, the 5, and then the 6. Okay, so we multiply each times its corresponding probability, and then we sum them together. Okay, so at this point, you can just type this straight into the calculator. and you would get your answer. So for example, you could do the 1 times the 1 over 6 in parentheses plus 2 times the 1 over 6. Got the parentheses there, and so on. But you could also do it. Let me put the parentheses here. You could also do it by hand because if I multiply by 1, that's just itself. So this would be just 1 over 6. 2 times, there's just 2 over 1, right? So 2 times 1 is 2. 1 times 6 is 6. So this will be just 3 over 6, 4 over 6, 5 over 6, and 6 over 6. Notice we want to add these all together. So I'm not simplifying because obviously 3 over 6 is 1/2. That's 1/3. But if I just keep it like this, all the denominators are the same. So I could simply just add the numerators together. So 1 and 2 is 3. 3 and 3 is 6. 6 plus 4 is 10. So that's nice. 10, 5 is 15. 15 plus 6 would be 21. Okay, so if you type this in or 21 over 6, you'll get the same answer. So both of these should give us the same answer. So either way, it should give us a mean of 3.5. Okay, so notice if I look at my distribution, we're finding the mean number of spots. And if I look at, we have 6 numbers, and since these are all equally likely, it makes sense that our average is 3.5 because 3.5 is right in the middle, right? We have 3 numbers here and 3 numbers here, and everything is equally spread out. So our average is 3.5. Okay, so I think about what this means. This is the average number of spots we're expecting. Obviously, if I roll a die once, it's impossible to get a 3.5. You could either get a 3 or a 4. But if we look at the long run, like if I rolled a die 10 times or 100 times or 50 times, then we would expect on average to have 3.5 spots. Just to simulate this, for example, so here I have a die. So let's say this is keeping track of the average. So let's say I roll it. So I got a 5. So obviously, we're far from 3.5, right? But if I continue to roll it, okay, got a 5 again. So my average, it keeps track is here. So my mean right now is 5. Um, okay, so we got a 2, so that brought it down. So notice as I continue to roll it, 4, we're getting high ones here. Notice in the long run, I'm just rolling one at a time, but I could do 10 rolls at a time. So if I do 10, 10, and 10, just keep spamming this roll button, you could see my average is 3.58, so pretty close. If I roll 10 more, went up 3.7. But on average, it is getting closer and closer to 3.5. So if I were to do this, let's say 100 times, went up to 3.8, but now it's going down 3.7, 3.6. You could see it's getting closer and closer to 3.5. So in the long run, on average, we'd expect and 3.5. So if I were to run the simulation again, maybe I'll get 3.3. But if I were to do it a million times, we would be pretty close to 3.5. So it's what we're expecting in the long run. The 3.5 might be a little confusing because obviously, like I said, it's impossible to get 3.5. But if I roll 2 dice, if I double it, 3.5 times 2 is 7, right? So it makes sense that 7 would be the most common sum if I add these together, the number of dots I see in total, because there's a bunch of ways to get 7, right? I could get 4 and 3 or 3 and 4. I could get 5 and 2, 2 and 5, 6 and 1, 1 and 6. So all those different outcomes give you 7. But if I look at 12, for example, there's only one possible way to get that, right? 6, 6. That's the only way I'll get 12. Same thing with 2. The only way to get that is 1, 1. But everything in the middle is more likely because there's more ways you could get there. So if I roll here, you could see on average we're a little lower, but if I were to do this once again 100 different times, you could see we are getting pretty close to that middle point. So it's a little below, it goes up. So 6.7, so pretty close to 7. So if I roll 100 more times, it'll probably go up a little bit. So on average, we're expecting um, total of 7 spots rolled. Okay, so let's go ahead and look at one more. Okay, so if I look at this one, it shows my random variable is the number of trips, 5 nights or more, so not just a short vacation, but the number of trips of that length that American adults take each year. Okay, so notice with this one, it's not evenly spread out. So if I look at A second, let me pull it up over here. So if I look at, right, we have 0, 1, 2, 3, or 4. So my middle number here is we have two numbers on this side and two numbers on this side. So if you ask yourself, would I expect an average of 2? Well, notice this one's not evenly spread out, right? Because most of my data is on, you should ask yourself, where's most of my data? So if I look at the left-hand side, we have what, 76% of the data? If I look at the right-hand side, there's only 4%. So you could see most of the data is on the left side. So this would be right skewed. So if most of my data is on the left side and not that much on this side, it would be right skewed. So I would expect my mean to be somewhere more on this side because most of my data set or raw data is um, distributed to the left here, which makes sense because if I look at the number of vacations families take each year, usually it's just usually maybe like one or two, maybe not even. Uh, Not many average families are taking four or more trips, so it makes sense that's on the lower side. Okay, so let's go ahead and use our mean formula to see exactly where it is. Okay, so I take each probability. So for 0, for example, the probability of that is 0.06. So I multiply each times its corresponding probability. So the 1 times the 0.70, 2 times 0.20, the 3 times the 0.03, and the 4 times the 0.01. Okay, so multiply each times its corresponding probability and then add them all together. And you'll notice we are going to type this one in the calculator. Can't really, it's harder to do by hand. Um, but when I am typing it in, 0 times anything is just 0, right? So I don't even have to bother. I do want to write it because it's a part of the formula, but I don't have to bother typing that in because that's just going to be 0. So if I do 1 times the 0.70, the 2 times the 0.20, once again, the zeros I don't need to type in, 3 times 0.03, and the 4 times the 0.01. Okay, so if I sum them all together, my average would be 1.23 or about 1.2 if it asked me to round to the nearest tenth. Um, okay, so as I predicted, so most of my data is over here. So instead of being 2, my average is closer to 1.2. So somewhere around here, which makes sense because most of my data is centered around here. So on average, just go back to the question, we're looking at the American adult. So obviously, if I look at a one or two, it's impossible to take 1.2 trips. But if I were to survey 100 random adults or 1,000 or a million, right? The more I do, the closer it'll be to 1.2. That's the average we're expecting that sample of however many to take. Okay, so if you want to try another example on your own, we can even go back to the last example. So like example 4 from the beginning of the lesson, we were looking at like the number of soccer goals. So if you want to try this one, try to find the average of this distribution. And you could see it's not evenly distributed, right? So if I look at my numbers here, the middle number is 3, right? Because I have three numbers here, three numbers on this side, but most of my data is once again on the lower side, right? So if I look at 30 and 20, that's like 56, like 60, 70% of the data is here. On this side, we only have what 831 is 12%. So like 70%, 12%. So once again, the mean will be probably somewhere in this area, not just the middle number. It's where most of my data set is. So if you were to look at, say, if you were to go to 20 soccer games, what's the average number of goals you would expect? So that's what the mean would tell us. So just being able to interpret it as well. So I would recommend trying this one. Find the mean of this one as practice. And yeah, that'll be it for this video. So that's how we find the mean of a probability distribution.